Hello everyone. I welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar. I am an assistant professor in SST College of Arts and Commerce ITCS department. Today we are going to talk about computer graphics and animation course, which is a part of semester 4. Program is BSc IT. The topic we are going to discuss over here is basic elimination model. So we have to understand what is this basic elimination model. So let's start. First we will try to understand what is mean by this elimination. Once visible surface has been identified by hidden surface algorithm, a shading model is used to compute the intensity and color to display for the surface. For realistic display of 3D sense, it is necessary to calculate appropriate color or intensity for that sense. See, this is basically the continuation of the earlier topics. Hidden surface detection is a technique which we use in 3D. Okay, so when the objects are overlapping, we have to actually find out which is the hidden surface, and that we have to omit. That technique is called that is done with the hidden surface algorithm. Once that thing is done, then shading model is used to compute the intensity and color to display for the surface. This shading model is used to find out the surface intensity, what is the light intensity and what are the color. Okay, and using that the realistic models are displayed. Elimination model or lightning model is the model for calculating light intensity at a single surface point, sometimes also referred to as a shading model. So here we are going to talk about the basic elimination model. So what is this elimination model? Is the calculation of light intensity at a single surface point. So if you see a surface at a particular point, what is the light intensity? That calculation of that is considered as elimination model. An elimination model is also called lightning model and sometimes called as a shading model, which is used to calculate the intensity of light that we could see at a given point on the surface of an object. A surface rendering algorithm uses the intensity calculation from an elimination model. So for calculating this, the surface rendering algorithm is used. So basically whenever a light fall on the surface, that time we have to calculate the intensity of the light. For displaying that actual surface, we have to calculate the intensity of the light at each point. That we can called as a elimination model. So these are some diagrams. So if you see, sometimes some of the light get absorbed. When a light fall on the surface, some of the light get absorbed, some light get reflected, and some light get transmitted. Okay, transmitted means it get absorbed. So this is how the things work. So either it get absorbed, or it get reflected, or it get transmitted, and they due to this the object become visible to you. Due to all these things, the object become, when the light fall on the surface, this is similar to our eye mechanism. Whenever the light falls on the surface, it reflects to your eye. Okay, and that makes that object visible to you. So same technique is used over here also. Elimination model, now we'll see the summary. Elimination model is used to calculate the intensity of the light that is reflected at a given point on a surface. There are many factors on which this lightning effect depends. So these are some of the factors. First one is light source, second one is surface, and observer. So what light source is there, whether it is a bright sun or candle, like that. The surface, whether the surface is absorbing the light or whether the surface is reflecting the light. And observer, of course, it depends on observer also, where he stand, how the light get reflect towards it. Based on all this, the elimination model is get decided. Now component of this elimination model, that is the what are the components we have to consider when we consider this elimination model? The first one is light source. So under light source we have to consider the type of the source, color. Of course, if the red color is there, light source is of red color, then all the objects will look red. If it is of blue color, so color, then the direction of the light source. So from which direction the light is coming, falling on the object, falling on the surface, that is also important. So type, color, direction of the light, this factor we have to consider when we consider the light source. The second component is surface properties, whether it is reflectance, opaque, transparent. Opaque means we can't see through, okay, transparent like a glass, shiny or dull. All these things affect when we consider the elimination model. So these are some images, okay. So bright sunlight is there. This you can consider the torch, and some of the color shades are there, you can see. Now the next we will continue with the components only. Object that radiates energy are called light source, such as sun, lamp, bulb, fluorescent tube, etc. So whatever tube lights we are using at home, that is called as fluorescent tubes. So object that radiates energy are called light sources, which are they? Sun, lamp, bulb, fluorescent tube, etc. There are many light sources. Sometimes light sources are referred as a light emitting object and light reflectors. Generally, light source is used to mean an object that is emitting radiant energy. Example, sun. Basically, it is light emitting sources. You can consider best example is sun. So it emits radiant energy. So these are the light sources. Then illumination model are used to calculate light intensity that we would see at a given point on a surface of an object. So what the first thing we learn? Illumination model. What is this illumination model? It is used to calculate the light intensity at a point on the surface, of an object. Lightning calculations are based on the optical properties of surface, the background light conditions, and the light source specifications. All light sources are considered to be point sources specified with a coordinate position and an intensity value. These are some assumptions. So light calculations are based on the optical properties of the surface, on the background lighting condition, and the light source specification. So this lighting is depend on these three factors, and all light sources are considered to be a point source. They are generating from a point. This is what a consideration is there. Now here we'll come to the different elimination model. The first one is ambient light, second one is diffuse reflection, and the third one is specular reflection and Phong model. Now let's start with ambient light. So this is just these are the images. The first one is ambient, then diffuse, then specular, and Phong. Okay, so this is the different models. Actually, this Phong you can consider as a combination of all these three, and which gives you actually the final model. Now next slide is ambient light. This is the simplest illuminating model. We can think of the model which has no external light source, self-illumination objects. A surface that is not exposed directly to the light source still will be visible if nearby objects are illuminated. If the surface is not exposed to the light source, but the nearby surfaces are light, okay, then automatically that not visible surface where the light is not falling, that is also visible. Fine. So you can consider a cube, the back side of the sides of the cube, the light is not falling on it, so they look darker, but when we see the image, we see the complete blob. Okay, so that is over here. The combination of light reflection from various surfaces to produce a uniform illumination is called ambient light or background light, also called background light. Ambient light means the light that is already present in the scene before any additional lighting is added. It usually refers to the natural light, either outdoor or coming through windows, etc. It can also mean artificial light such as normal room lights. So what is this? Ambient light is the light which is present naturally, like sunlight, or if the light which are coming from window, or at night if we on the tube lights in the house, then that light we can call it as the ambient light. Then the second one is diffuse reflection. Objects illuminating an ambient light are uniformly illuminated across their surface even though light are more or less bright in the direct proportion of ambient intensity. Surfaces are rough. Incident light is scattered with equal intensity at all directions. Surface appear equally bright from all directions. Such surfaces are called ideal diffuse reflectors, also referred to as Lambreation reflectors. See what happens now? Usually these surfaces are rough, and when light fall on the surfaces now, it gets scattered in every direction. So from all the side it looks properly illuminated. So that we call as a diffuse reflection. The next one is specular reflection. When we look at an illuminated shiny surface such as polished metal, a person's forehead, we see a highlight or bright spot at a certain viewing direction. Such phenomena is called specular reflection. Whenever we see any object, maybe on my forehead you might be seeing a bright spot of light, or if there is a vase or any circular area, you can see some bright spot. That spot is called as a specular reflection. Okay, it is a result of the total or near total reflection of the incident light in a concentrate region around the specular reflection angle of incidence. So it is actually some reflections get converge, means come together, and they gives you that bright spot over there. Perfect reflector mirror reflects all lights to the direction where angle of reflection is identical to the angle of incident. It accounts for the highlights. These areas we usually called as a highlights. So we understand what is mean by reflection models, and so this illumination model that is used to calculate the light intensity at a point on the surface. Then we see the three models, that is ambient light, diffuse light, and specular reflection and Phong model. This is the image for the same. Ambient light is the sufficient light, daylight or light coming from the window, or at night if we'll on the bulbs or tube lights in the home, that we call as the ambient light. Diffuse light is the surfaces are rough and light get reflected in every direction. So the surface look perfectly bright from all the direction. So this type of reflection is diffuse reflection. And the last one is specular reflection. So under specular reflection we consider the highlights. So whenever the light falls on the object, there is some highlighting point. That points are called as a specular reflections. That's all for today. Thank you everyone.